Hello, this is Mr. Jackson again with Physics A, and today we're going to talk about distance time graphs. So I want to start off with an idea of distance time graph, and I want to share with you this idea of what they are, and they have quite a bit of information hidden within the graph, more than we expect. Now, a distance time graph is simply a graph where we have distance versus time, and it's really simple. But what I want you to understand is that you need to make sure you always check the units of your graph, because graphs can always change. So get an example. I want to look over here on the right. I've looked up distance time graphs on my Google, and you can look in here. You can see that distance time graph, this one right here, is in kilometers and hours, so it changes the whole meaning of what I'm going to read for what the lines mean. So the first thing you always want to do is you want to make sure that here is meters per second. Okay, so I just want to point out that we need to make sure you always, number one, look at the units. Look at the units, because that really can change what the graph's about. Okay, so as we go through, I want to write down more things. Okay, the first thing I want you to know about a distance time graph, sometimes called a position time graph. So sometimes it's called a position time graph because it actually is showing your position at the same time. So as we go through, I want to point out what you can get from this graph. So the first thing you want to know is that the x-axis, which is this axis right here, is actually called the origin. And the origin means that's where measurements are made from. So if this object is moving up and away, so this object right here, let's say object A or whatever, it has moved so far from the origin. This would be our 0, 0 point. Okay, and we got to be careful. That is not always the starting point. It may not be the starting point. And this is important to understand, because if an object is right here, and let's say that we have, like on a track, you have kids that can start at the starting point, but then maybe it's a staggered start, then maybe another person may start up in front of them and they're running like this. So this person's starting point is right here, so they are so far in front of the origin, so it lets me know that these two objects started at the same time, but one was ahead of the other. So this was this person's, or we'll call it two things. Let's say this one's B and this one's A. B did not start at the origin. It had its own starting point that was a little bit ahead of the origin. But the origin is where all things are kind of referenced to. Okay? So that is a piece of information. Number three, the third piece of information we can get is that we have sometimes lines that are sloped, yes. And sloped actually means that the object is in motion, and in fact the motion is constant velocity or constant speed. And what I mean by that as time goes on, if it's a straight line, that object over time is continually making the same changes per time. So that is constant velocity when it's a straight line. Okay? So it needs to be straight. And we are going to change those ideas here in a minute or so. So here we look at our graph. We have this graph right here. So this object right here on the far right is moving at a constant speed. In 5 seconds it goes 10 meters, 10 seconds it goes 20 meters. So at 15 it should be at 30, and there it is. And at 20 it should be at 40. So that's a constant speed. Each chunk of time is moving at a constant speed. But we got to be careful. Here's a graph where we have a constant speed, but here we have a steeper slope. So what's going on there? So we want to know that a sloped line tells me the speed, but a steeper sloped line means a greater speed. So this spot right here on this graph shows an object between A and B going a certain speed, but between C and D, the same object now has sped up. So that is something you need to know. So we got here a steeper slope is a greater speed or velocity. Right now I'm just calling them speed and velocity. So less slope, less speed. Okay? That's important to know. The fifth thing we talk about is actually calculating that speed. How do we find slope? The slope is equal to rise over run, or change in y over change in x. And if we really got detailed, it really is equal to y2 minus y1 over x2 minus x1. That is the best way to do slope. So let's do an example of slope calculation. Let's say we have two objects, okay, and I do two different graphs, and these are distance time graphs. And these two objects we have at 0, 0, so the first object goes out, and in 4 seconds, 1, 2, 3, 4, it moves 4 meters. 1, then we go up here and over, so here, 2, 3, so 1, 2, 3, 4, okay? And then the same thing is here, we start at 0, 0, but I'm going to go 1, 2, 3, 4, 5. I'm going to have this object start here, so 1, 2, 3, 4, so this object at 4 is at 5, so I'm going to go like this. So the slope is the same, so they should be going the same speed, but if you have this constant habit of just picking one point instead of two, you're going to get an inaccuracy. So here's what we said. This is 4, and this is 4 on seconds, and we'll call these meters. And then this is 5, and this is 4. And let's do the math. Slope is rise over run. So if I pick these two right here, and I go rise over run, I just say I picked one spot, 4 over 4. So I said 4 divided by 4, because the slope is rise over run. It went up 4 and it ran 4, and that's meters per second. I'm going to get 1 meter per second. So I told you it gives me our speed. Okay? But then what if I do this one, and I go now, I'm going to just pick one spot. I'm going to pick the 5 over 4. Let's say that that's what I choose. Then what happens is meters per second, I get 1.25 meters per second, but that is not the correct answer because I told you these slopes are the same, so they're going the same speed. If I would have picked 2 points, then what would have happened is I would have actually gotten this situation where I would have put the numbers in, started at 1, 1. So here we go, 1, 0. So the first data point that I have is 1, 0. So the time was 0, but I started on the y-axis at 1. I went to 5, and then I went up to 4. Now, meters per second, I get 4 divided by 4, 1 meter per second. So I actually now have the same answer because I used 2 data points. So whenever you're doing the slope, if something doesn't start at the y, 0, 0, you can't pick just 1 point. You have to pick 2 to get an accurate answer. So I want to point that out. Be very, very cautious about that. That's important. Okay? The next thing I want to talk about is what happens when a line goes flat. So let's look at our graphs over here. Here we have a graph situation. We have 2 flat spots. Well, what's going on? Here it's telling us that at around 5 hours, B is at roughly 3 kilometers. Then at 8 hours, it's still at 5 kilometers. So what's happening? It's staying in the same place. So what we know now about our graph, what I put down here is number 6 on our chart, is we have this. So we have our distance time graph. We have number 6, and what we have is that a flat line means rest, or 0 meters per second. Okay? It's not moving. Okay? That's something you need to have. Sometimes they call that a no slope line. A flat line means no slope. Okay? That's what you need to do. Well, what does all this other stuff mean? Let's look at our graph again. So we have our graph that we're going to look at here. Whoop, I got to go back. That's not what I wanted. And I wanted, oh, not that either. I wanted to enlarge this one. Here we go. And so we have this graph, and we have different spots that are flat. So this object is at rest at different places in time. Okay. But what happens when the graph goes down? What does that mean? Well, that means that when you go down, if I plug my numbers in, I'm going to have a slope line down, a down slope. That means a change in direction, because what happens is we're now heading back towards the origin. So whenever a object moves out in a way, so this object at A started at this spot called the origin, it moved out, then from E at F it came back to the same place. So that means to return. So if I looked at this graph, these two objects right here, there's a blue line and a red line, they both kept moving away, and they have stayed. They have never returned to where they started from. They are out at some distance. So that's another idea. So whenever the line has a downslope, or it goes back down towards the origins, or changes slope back to the it means to change in direction. Okay, and the next thing we need to talk about is, what does it mean when we are dealing with a situation where we have maybe a line changing. We said we have angles, and we have curve. Let's look at a curved one. Let's look at this one here. We have a curved here, and we have this one with flat lines and angle back to the origin. This one moves away. But what does this curved line mean? Okay, we need to talk about that for a second here. A curved line, a line with a curve, actually means that the slope is changing. And if the slope is changing, the speed or velocity is changing. And if you're changing your speed or velocity, you are undergoing what's called as acceleration. And it could be positive, or it could be negative acceleration, which is called deceleration. But it's not hard to figure out. So we just have that information. So here we go. We have this idea. We have acceleration. Here it is. Okay. So if I've got a line and it curves upward from distance time, that means I had a slope here, but then my slope is steeper. So I'm getting faster and faster. So my slope is increasing. This would be called positive acceleration. Okay. But if I have a line that is decreasing, and I'm heading towards a flat line, here I have some speed because I have a slope. Here I'm getting flatter, which, remember, flat line was at rest, so I'm actually approaching a zero speed, so then that would be deceleration, which means I'm slowing down. So curvature on the line can mean positive or negative, but you got to be careful. You got to look at the beginning and the end. Is it getting steeper? If it is, you're accelerating. If it's getting shallower and flatter, you're decelerating. So it's not a very hard situation or thing to understand. Just make sure you're watching the angles and that kind of stuff. So to recap all of this stuff, we have lines that if they have a slope on a distance time graph, they mean that something's traveling at a constant speed. A steeper line, so if I took a line and made it really steep, let's take A, all of a sudden decided to go steeper, then A has gone faster because it indicates a steeper slope, means greater speed. If that line then flattens out, we have learned that that means that we are at rest. If that line begins to turn and go back towards the origin, it means it has changed direction, and now it's heading back in a new direction. So this means a change in direction. So when I get a downward slope, you have a change in direction. It also means that you're going in a new direction. And remember, if you have velocity and you have a negative direction over time, you're going to get a negative velocity, which means also a change in direction. Okay? So that's important to understand. And then we had our last idea that if we have a curve to it, then in that region we have some kind of either acceleration or deceleration. Here I have a slope. Here I do not have a slope. I'm heading towards a flat line, so that must be negative deceleration because I'm heading towards a flat line. Okay, so these are the things you need to know about distance time graphs. You need to know how to read them, you need to know how to calculate slopes, and you need to understand what the graph is telling you at different times. So whenever you're looking at different kinds of graphs, so let's look at one really quick here just to finish out this video. We have this line here. We have one object, the green one, going at steady fast speed, it says right here. Here we have one where the slope is increasing, the red one, it says accelerate, it says decelerate because it's curving down, stop at the top. Steady speed here for this blue one, but that means it's going slower than the green one. And then here it says steady speed, return to the start position, so it has changed direction. And so that kind of stuff. And you need to know those things, and you need to know how to calculate the slope. We will never do the slope of a curved line. That is not the math we are going to be responsible for. Okay? So that is distance time graphs in a short form. Okay? Have a great day. Blessings.